My name is Stephen de Vries. I'm an independent security consultant. I'm specialized in web application security and also in secure development practices. And today I'd like to talk about sheep, in particular a black sheep of the automated software testing world, which is security testing. You know, if we look at the way that developers are currently writing their code and currently testing their code using automated techniques, they're broadly using two types of testing. Unit testing, where they test small blocks of code, and integration testing, where they're either testing entire components or they're testing the whole application. Security testing then typically isn't integrated in this process at all. Very few organizations are integrating security tests inside their integration or unit tests. And typically security testing is done right at the end of the software development lifecycle. So after the product has pretty much been built, they then run, either have external consultants come in to do a manual web application assessment, or they run some kind of scanning tool to do an automated security test of the application. If we look at what unit and integration tests actually bring to the table, the advantages they give to writing robust software, one of the important things is that it is developed alongside the code. And in fact, in test-driven design, the tests are written before the code. So the test can actually become the specification for the software. So instead of writing the specs for the software in a Word document, then handing out this document and everyone promptly forgets about it when they start writing code, you have a set of tests, and these tests define the specification for your software, which means that the tests and the specs change as you add more functionality to the software. You have measurable test coverage. How much of my app is tested? Well, just go and check the test cases. How much of the app are they actually testing? They are completely automated, which means that you have free regression testing. Anytime you make a change to the application and you want to know, has my change broken anything, you simply run your integration tests. The tests run and you can see, have any of the tests failed and have I broken something somewhere else in the application. A few years ago, I was on a sales call with a client to do a manual web application assessment for them. And I was giving them the standard rollout about how we would be doing the assessment, what can they expect in a report, and so on. And the project manager was quite happy with our approach, and their security guy was happy with our approach. But there was a software test manager present on the call, and he had a few questions. So the very first thing he wants to know is, can we supply a list of test cases that we would be running against the application? And I had to say, no. Well, we follow a methodology similar to the OWASP testing guide, and I can hand you the methodology, but I can't hand him a list of specific tests that we'd be running. So he was okay with that, and the next thing that he wanted to know was, so in our report, would we have both a list of the passing tests and the failing tests? And I had to say no, because in a typical vulnerability report, we just report on the vulnerabilities. We just report on the problems, in other words, the failing test cases. And his final question was, so if we do find problems in the application, and they then go and correct it, how does he test whether they've actually corrected them properly and they have actually addressed those issues? And like any good consultant, I said, well, he'd have to hire us again, and we'd come in and do a retest and an updated report, and so on. And I could see he wasn't really happy with the situation, and at this point their security guy jumped in and said, look, you know, this is just the way security testing is done. It's necessarily different to the rest of the automated software testing world. And that got me thinking, you know, is security testing really that different from integration testing and from the integration testing tools that developers are currently using against their applications? And I don't think it is. I think there's a huge chunk of security testing that can very easily be done in integration testing tools and using integration testing methods. So what I'd like to focus on in this talk is not so much the why of integrating security into the development process, but more the how. And I'd like to touch on three topics. Firstly, behavior-driven design, which is a natural extension of test-driven design. Secondly, the Selenium page objects pattern, which gives us a nice maintainable way to write browser automation code. And thirdly, how to integrate the burp security scanner as part of an integration testing approach. So before I get into behavior-driven design, let's just have a look at a standard, simple integration test. Now, in order to do an integration test on a web application, you need two broad components. The first component is you need some way to programmatically drive a browser. And a very popular tool for that is Selenium. And currently, the latest version of Selenium is Selenium 2, also known as WebDriver. WebDriver supports a bunch of, well, I think almost all the popular browsers, including iPhone browsers and I think Android as well. Using a standard API, you can then drive the browser, program the browser to go and do things for you. The second component is you need some kind of testing framework. So JUnit in Java, NUnit in C# and so on, and all the languages have their own testing framework. So this simple test uses WebDriver and it uses JUnit. So right at the top there, if I have a mouse, I don't, there we go. So right at the top, we first define a login function. The login function gets the login page. Using WebDriver, we then find the username field, we send it the username, we find the password field, we send it the password, we click on the login button, which happens to be called update in this case, and we have a programmatic way to log into the application. Now we can write our tests. So basic functional test, we want to test that login works with the correct username and password. So log in with Bob and password, and then check the resulting page. If that page contains the word welcome, we know that we've successfully logged in. Similarly, we want to write a failing test. We want to check that if we log in with Bob and the wrong password, Messerschmitt, and getting the page source, we must find the word invalid on that page because the resulting page contains the phrase that was an invalid password or an invalid username or whatever. Okay, so that's a simple integration test. And if a developer wanted to score some points with the security guys, he'd write a SQL injection bypass integration test. So you'd try and log in with Bob and an SQL injection string to try and bypass login. And as you build the application, so you expand on the integration tests that you'd be running as part of the application. These tests are your specification. So as you need to add more functions, you add more tests. And in test-driven design, you first add the tests, and then you build the functionality in the application. Anytime you want to know, is my app behaving according to spec? Run the tests, and you can find out. The other point about automated tests is you can integrate them into a continuous build environment. So for example, every time developers commit some code to the development server, that server will then build the code, deploy the application, and run the integration tests against the new code automatically. So you can effectively have a daily report of what code changes have happened and how have they impacted the specifications of your application. One of the problems with, so if you decide that you do want to use automated tests to now define the specifications for your application, one of the problems is that only developers who understand JUnit or the testing framework can understand what the specs of the application are, because all the tests are written in Java or in Ruby or in whatever. And one of the advantages of behavior-driven development is that it brings communication to the table. So what it effectively allows us to do is for business stakeholders, for business analysts, or for security architects to write the specifications in an English or in a natural language, and then have developers wire that specification to code. So we have the kind of the best of both worlds here. The business analysts can define the specs in a natural way, but those specs can still be executable, and you can still run them at any time. This was our original SQL bypass integration test. So log in with that, and then check that the page contains the word invalid. Using a BDD framework, we can change that test and write it like so. Now this is JBehave, which is the Java BDD framework. For Ruby, there's RSpec and Cucumber. For Python, there's Lettuce. EasyB for Groovy, and so on. There are a lot of different BDD frameworks. I'm going to be focusing on JBehave for the rest of the talk. This is very similar to Cucumber, which is also a popular web testing framework. So as you can see, this is extremely accessible to anyone. You don't actually have to understand the code to be able to read this. It's a scenario which corresponds to a test, and a scenario consists of individual steps. The only criteria with these steps is that they start with special words: given, when, then, and. So once we have that spec written in an English language, the developer would then wire that spec using Java annotations to individual bits of code. So the framework then knows when it receives the step, given the login page, it needs to run that code. And you can see the code steps are the same as what they were in our integration test. So it's very easy to rewrite those 3 tests that we had into JBehave steps, which is much more readable. And if you look at those scenarios, they're actually all the same scenario. The only thing that's different between each scenario is the data that we're feeding it. So we're first logging in with Bob and password, and we want to see the word welcome. Then we're logging in with Bob and blah, and we want to see the word invalid. Then with Bob injection and blah, and we also want to see invalid. So JBehave, because this is quite a common pattern that you're going to see in your tests, they've made this easier to do by providing an examples table in the JBehave test. So we can refactor our scenario, and we can use individual parameters there. Okay, so when the user logs in with username and password, then the match word should be on the page. Then we provide an ASCII table of the data we're going to send it. And JBehave runs the scenario for every row in the table to see if it passes or fails. So let me show you this in action. So for all the demonstrations I'm going to run, I'm running on a very simple web application. It supports login, adding things to a shopping cart, and so on. Yeah, it's got a sign-in form, sign-out form, and so on. So this is the JBehave story, and there's a JBehave plugin for Eclipse as well, so you get some kind of syntax highlighting of your story. And JBehave also provides a JUnit wrapper, which means that you don't need any kind of special setup to be able to run JBehave tests. It wraps them in JUnit. So anything that can run JUnit can also run JBehave tests. So we can run this as a JUnit test. And it's using currently the Firefox driver, Firefox web driver, so it's going to start up Firefox, which is not instantaneous. There we go. And it's run through the scenarios, and we have our results. JBehave will produce 3 sets of results. It'll produce text, HTML, and XML. So we can use those. We can either feed them to other programs, or we can view them in the browser. And this is a result of the authentication story. This is the summary page of all the JBehave stories that we've run. So we've just run this one story, authentication story. It consists of one scenario with one fail scenario, and here are the details. It gives us the actual scenario that it ran with the data table, and then the result of each row in that data table. So Bob and password, it got the word welcome, everything in green, it all passed. Then it tried Bob and blah and the word invalid, which was correct as well. Then it tried the SQL injection, Bob injection and blah. It expected invalid but didn't get it. So the scenario failed. And we know the application is vulnerable to SQL injection in the username field. Okay, so that's a quick intro into JBehave and what native, just bog standard JBehave can do. Now if we go back to the code, the WebDriver code, you can see it's a bit ugly, right? So you can imagine if this is a very small test, that's all right. But if we had, say, 100 or so different scenarios, we would have this WebDriver code about how to find different elements on the website, what data to populate it with, and so on, would be littered all over our tests. Now imagine a web developer goes and changes the name of the username text field on the login form. All of a sudden, our tests are failing all over the place. And we need to go and debug it and find out, change the name to the new name of the username field for the test to pass. This is exactly the kind of problem that the Selenium page object pattern was meant to solve. page objects says, in a nutshell, let's treat web pages as if they were objects. So every page is an object. Every function you can perform on that page is a method on that object. So with a login form, we would have a login method defined on the login page. Technically, we'd also have a search method on that login page. What it means is that we can take that code and we can change it to that, which is much more maintainable. So we've hidden the implementation details of exactly how to log in, how to find the form, and how to enter the details and so on. We've hidden all that data in the login page object. Now, when we need to change it, when something changes on the login form, we just need to update it in one place in that login page. The other nice thing about page objects is they are shareable and reusable. So if you have guys already doing integration tests and they're already creating page objects to navigate through your application, you just need those one set of page objects. And you can then share them out between different teams. The performance testing team, for example, could use them to do performance testing, driving data through the browser. You could write your own security tests to use that page object as well. This is what a simple page object would look like. This is the login page. So first thing you do is extend a base class page, which does some work in the background for us. Define the URL. Where do we find this page? Then define any HTML elements that you want to use within the page using the web element type. So we have a username, a password, and an update button. What Selenium does in the background is it matches the name of the variable to the name, or first to the ID of the HTML tag, and then to the name of the HTML tag. So as long as we give them the variable the same name as what they are on the page, we don't have to do anything else. It'll automatically go and find them on the page. And we can then write a very simple login function, which just basically sends the data to the username, password, and clicks the update button. So what we have here are two quite powerful concepts. BDD gives us a way to write English language specifications for an application, which are still automatable. So we can run them at any time we like, and we can know whether our specifications are passing or failing. We have page objects, which gives us a nice clean way to define all this browser navigation code. So when we do have to maintain it and we do need to change something, we just need to change it in one place. So I thought it would be a good idea to bring these two concepts together and create a framework called Bdd Security. No shortage of imagination here. And basically, it's a security framework that allows you to do testing of web applications using JBehave and using the page object pattern from Selenium. What it is essentially is a set of security stories or security specification templates for web applications. Because, I mean, at the base of it, a lot of web applications are pretty much going to have the same baseline security requirements. If an app provides login and logout, there's going to be a baseline of things that you want it to do. You want the login page to be served over SSL. You want the password to be case sensitive, for example. So all these kind of baseline specifications are written in a set of templates. And you shouldn't need to change those templates between different applications. The same set of templates should be able to run on almost any web application. Then it uses Selenium 2 WebDriver and page objects to give us more maintainable code. I like to think that this gives us a kind of a deep automated testing. So instead of just doing an automated scan on the surface of the website or logging in and then doing a scan, this gives us really deep testing into the application, because you define with your Selenium code how deep the testing goes in the app. So you can follow workflows, you can follow complex workflows, and you could submit the correct forms in a wizard, for example, to get to the final page, so that you're still testing towards the back of the application and not just on the surface. Since it's JBehave, it will run on any Java build tool. It runs by default on Maven, it will run in the IDE, and so on. This is an overview of what the framework looks like. In essence, the important part are the security story templates over here. So these are the predefined templates, which I don't believe you should need to change between applications. You might need to change some specifications to suit your particular application, but as a baseline, I think they provide 90% of what you'd need to test with an app. Oops. Then, the reason that they can be templates is because they expect to talk to a number of interfaces. And these interfaces are the bits that you would need to develop in Selenium. So you'd need to implement things like login, logout, and any other features that the web application provides. You do this by defining a Java class, which extends from a base class. And then you can write custom stories. So of course, if you want to do some good security testing and record those security tests, you also want to test the business logic of your application, the security logic of the application. And you can use the functionality provided by the framework to do that quite easily. So to get started with Bdd Security, first thing you need to do is define the default driver that you're going to use. The problem with Selenium is Selenium was designed to do functional testing. The Selenium guys want to write tests to make sure that your page renders the same in Chrome as it does in Safari as it does in Firefox. So they've decided to not give you access to the HTTP layer in the Selenium driver, in the WebDriver API, which is a bit of a pain in the butt for doing security testing. So what I've had to do is extend some of the drivers to give you access to the HTTP layer. So right now, Bdd Security only supports HTML unit and Firefox, but it will support the other browsers quite soon. So first thing, tell it we want to use the HTML unit driver, which is a pure Java driver. It's quite fast, but it's bad at interpreting some JavaScript. Tell it the base URL for the application that you want to test. Then name the class that defines how your application behaves. Right now, you need to tell it the name of the session cookie. This is so it can do some session management tests. And in the future, this will be automated. You can find that out for itself. Right, then you need to define the list of users. Who are the valid users of my application? Define that in the configuration file, and a few other bits and bobs you can define as well. This is the meat of the framework, or the part that you need to do as a tester or as a developer to write automated tests. First thing you do is define your application. So in this case, it's called iSpatula application. It extends the base class web application, and then it implements the functions that this application implements. And the story templates that will run will depend on what you implement here. So if you implement iLogin, it will run the authentication tests. It will run the session management tests. If you don't implement iLogin and iLogout, it won't run those tests. So when you do implement iLogin, first thing you need to tell it is how to find the login page. Then you need to tell it how to log in. You also need to tell it how to check that a user is logged in with the isLoggedIn method. So over here you can see we're using page objects to do this. We're opening an account information page. If that page opens properly and we see the text we're meant to see on that page, then return true because we're logged in. If that page throws an exception, in other words, we can't open it, then return false because we're not logged in. So you're free to implement this however you like, as long as it accurately reflects if a user is logged in or not. Let's see some of this in action. All the stories are here in one directory, source main stories. We have authentication, authorization, automated scanning, configuration, and session management. So let's look just at the authentication story. And the story consists of a number of different scenarios. Scenario, password should be case sensitive. Next one, scenario, the user account should be locked out after 4 incorrect authentication attempts. Login should be secure against Sql injection, and so on. The story itself is tagged with a meta tag so that we can identify the story within the framework. What this means is that it allows us to run just the story if we just want to run authentication tests, or we can say skip just the authentication story but run all the other ones. So right now let's run the authentication story. You can do it on the command line. I've configured Eclipse to run it. So here we're running with the meta tag. Just run the story called authentication. And again, it's using the Firefox driver, which is a bit slow. HTML unit is by far the fastest driver to use, but it's a bit unreliable with JavaScript handling. So I would tend to use HTML unit where you can, unless the web app doesn't play nice with it, then you can switch to Firefox instead. So it's running through all the authentication scenarios at the moment. And you can see the output as it's running through each step over there. And that's done. Now we can go and view our reports again. And we have a new story here, the authentication story. 7 total scenarios, 2 were successful, 5 failed. And we can go check the details in HTML. Password should be case sensitive, that passed. User account should be locked out after 4 incorrect authentication attempts, that failed. So it logged in 4 times. When the default password is used again and the user logs in from a fresh login page, then the user should not be logged in, but the user was logged in. So the account wasn't locked out and the scenario fails. And so on for the other authentication tests. Okay, so these are quite straightforward. I think we could call them functional security tests, right? We want to test that the login function behaves as we expect. But what about doing something a bit more complex? So if you notice on this iSpatula application, it supports 2 different user roles. There's an admin user An admin user has a function that only admin can use called list all orders or list orders. Right? When they access that function, they see the word all orders on the page and they see everyone's orders that have been placed. If a regular user like Bob logs in, Bob can also try and access that page. And what he sees is my orders and a list of only his orders. Okay? So how to test this in Bdd Security? First thing we need to do is we need to tell the framework about the different user roles. So we simply add another XML line there saying which user belongs to which role. Bob is just in the user role, so is Alice, but the admin user is both in the user role and in the admin role. That's easy. Next part's a bit more complex. Now we need to add another method to our application class that goes and accesses this restricted method. So we'll call this method listAllOrders. And we're using a page object again to open the listAllOrders page. If we see the listAllOrders page, then the method completes successfully. So to do the access control test, or do the authorization test, we need to annotate that method with the role that's allowed to access it. In this case, only admin is allowed to access that particular role, or that particular method. And this is the templated authorization story. So you don't need to change this. This is what the Bdd Security framework will go and run. As you can see, it's using the examples table at the bottom. What it does is quite simple. It knows which users belong to which roles. It also knows which methods are restricted based on the roles. So it goes and builds out a table of users who are not meant to access a particular method. It then goes and logs in as the user and tries to access that method. If it can access that method, if it can access that page, then that's an access control violation. If it can't, then the scenario passes. So key to this working properly is this list all orders page, which is the page object we're using to define this list all orders page, right? And we have to do something special here. We have to override the verify method on the page object. The verify method is always called on the page object when the page object is opened, right? And verify should throw an exception if it's not on the right page. So all we've done here is we've defined some text saying the special text we want to see is all orders. If we don't see the text all orders on this page, then we're not on the page. So with this bit of code, we check the source, we look for all orders. If we don't find it, then throw an unexpected page exception that we're not on the right page. So I'm going to run this test, and before I do, I'm going to change it to HTML unit just to make it a bit faster. So I'll change the driver, HTML unit driver, like so. Then the authorization story at the moment just has this one scenario in it. It's tagged with an ID, and the entire story is tagged as well with a meta tag. So we can run this. So you're not going to see a browser anymore because HTML unit is pure Java. But what you will see is incredible speed. Logged in as different users, trying to access a method, and it's done. And here are the results of our authorization story. You can see the details over there. So verify that only authorized users can view restricted resources. This is the detail of the scenario that it ran. And here is each row from the table which it automatically generated for you. So we tried with Bob and the password, and Bob was not able to access the list orders method. Correct, scenario passes. Same thing with Alice. So we know that access control is properly implemented for the list orders method. So what about scanning? Well, I know the talk's called Beyond Scanning, but I still think scanning is an extremely useful part of doing a web application assessment. As long as you're scanning all of the application and you really are testing the depths of the application. And that's something that you can do when you have integration tests or browser code that's driving the scanner deep into the application. So instead of rewriting a scanner, I'm going to integrate with the Burp tool, the Burp web scanner. And since it will be really nice to be able to talk to Burp as a web service, releasing a new tool today as well called RestyBurp, which is basically a RESTful web service that starts within Burp and allows you to talk to Burp over JSON, and you can then control Burp and get it to do things. So you can get it to scan a target, find out the completion status of that scan. You can return the issues that Burp has found for that scan, get back the entire proxy history, and get set update the configuration. So I think it might be useful for other languages, because right now it's shipped with a Java client because I happen to program in Java. But of course, if you like using Burp and you want to programmatically access Burp in some other language, you don't need to use Java. You can write a JSON client in Ruby or Python or whatever and talk to Burp and get it to take actions. So this is what RestyBurp looks like on its own. So it's shipped as a Maven project, so you can start it up with the Maven exec command. This starts up Burp and the service within Burp. It starts up the Burp scanner with a blank scanning policy. So nothing is selected, no scanning option is selected there. You can see there the Jersey app started on localhost 8181, which is where you'll find the JSON web service that you can talk to. The default client that comes with it starts up a Groovy Console if you just run the client itself and don't use it as an API. So the Groovy Console is a handy way to prototype some actions with Burp if you just want to see how it works. So with this script, we've written a very short little script here to just do some elementary Burp actions. First thing we're going to do is we created a new scanning policy, and this is going to be a reflected XSS and a stored XSS scanning policy. We then set that policy on Burp, and we then ask Burp to scan a particular URL. we wait until that scan is 100% complete, then get the issues and print them out. So fairly simple little script there. First thing we're going to need to do is drive some traffic through Burp. Since this is just REST Burp on its own, I'm going to drive the traffic through manually with Firefox. So just do a simple search action. Now we can run the, just showing you the blank policy and running the script. And there he goes. And you can see that it's dynamically updating Burp. It's changed the config, and now it's performing the scan. And you have the completion status of the scan over there. It found one XSS vulnerability, which is also what Burp found. In this case, I'm running Burp in GUI mode just so you can see what's going on, that it is actually performing actions and so on. But you can run Burp in a headless environment, so you can stick it on a headless server, and you can interact with Burp over JSON, and you don't have to see the GUI at all. Right, so that's REST Burp on its own, but of course the point of it was to integrate it into Bdd Security. And this is how it's integrated into the Bdd Security framework. So because you want to do scanning as well, you need to implement a particular interface, and this in this case is called iScan workflow. And iScan workflow, you need to implement the navigate all method. And navigate all is exactly that. In navigate all, you should navigate through the entire path of your application. So go through all the wizard forms, submit all forms with valid data to get to every part of your application. And the wonderful thing about using page objects is if you have them already defined, you can just string them together now. So create a new search page, open it, then search for the word hello. Then open the login page, log in with the default credentials, and then open an account information page. Let me show you the whole thing end to end. So first the automated scanning story, which looks like this. So instead of running Burp with, let's say, a big bang scan, just scan everything, instead I've broken it down into different vulnerability categories. So first, Burp scans for SQL injection, then it scans for cross-site scripting, then it scans for command, XML, and so on, so that you have better control of what you see from Burp and what you send or what you use Burp for. So if you wanted to, you could run just the SQL injection scan, for example, and nothing else. Or you could skip that particular scan. And this is what it looks like. If you just run the story runner without any arguments, it will run all the tests. So now it's going to start off. In this case, I'm using Firefox again. And I should mention the very first story it runs is called the configuration story. If you've screwed up the config somewhere, so you've given, you used the wrong password for a valid user, the tests are going to fail. So what configuration story does is it first runs these elementary configuration tests just to make sure everything is working as expected, and then it launches into the rest of the security tests. So you don't have to wait 20 minutes or so for all the tests to finish before you realize that something is amiss with the configuration. Okay, so it's run through the authentication tests. And this is a speeded up version, by the way. It takes a few minutes to run through everything. And it's ready onto the Burp tests now. So you will see it reconfiguring Burp for different scanning policies. So the SQL injection test is running now, so it turns on SQL injection scanning. Finishes with SQL injection, moves on to cross-site scripting, rescans those same forms, but for cross-site scripting this time. Now it does OS command injection, LDAP, XML, and the final set of miscellaneous tests there. And the final story it runs is the session management story, and it's done. And this is what the final report will look like. A list of all the stories that have been run. We can see how many scenarios have passed, how many have failed. Session management, configuration, automated scanning, authorization. Let's have a look at the automated scanning one, which is the burp scan. And here are the details. So the very first scan was the passive scan. So passively scan for vulnerabilities. Given a passive scanning policy, when the application is navigated and the scanner is run, then no vulnerabilities should be present. Unfortunately, 8 vulnerabilities were present. And it lists each of the 8 vulnerabilities here in the error message. So you know which field in which URL was responsible for that vulnerability. Same thing for SQL injection. It expected no vulnerabilities. Instead, it got 3 vulnerabilities. And it lists each of the injection parts here. This is the data that it has grabbed from burp. Okay. It also happens to store the burp results in raw form in XML for each of the scans. So scan SQL, for example, you can go and have a look at the XML result for that. And it's an XML formatted burp result, giving you the content of the HTTP request that was sent and the content of the HTTP response that came back. So if you wanted more details from burp, you could parse this file and then get the details from there. So to summarize, what we have with Bdd Security is a set of templated security specifications written in JBehave, so ordinary people can understand it. Security architects can use it and read it without having to understand the testing framework. We have automated security regression testing. All those stories can be executed every day, or they can be executed whenever you need them to be executed. So you can find out if a change to the application has had some kind of security impact on the app. The page object pattern then gives us maintainable page objects, maintainable way to navigate the application. An app is going to change. There are going to be new features. People are going to rename the forms and rename fields in forms and so on. And page objects gives us a nice way to have maintainable browser automation code. The other advantage that I mentioned earlier is that if you already have an integration testing team that's using these page objects, they've written their own page objects just to test that browsers are working, to test the functional aspects of the application, you can reuse those page objects in the Bdd security framework. You don't have to go to the trouble of navigating the application. And the final piece of the puzzle is REST burp, which gives you a web service into burp, and it's integrated into the Bdd security framework, so you can run particular tests using REST burp. The two tools, Bdd Security and REST burp, are available on continuumsecurity.net. They're both GPL open source, and you're encouraged to contribute. Who has the first question? Yeah.
Nice presentation, Steve. So, let me just ask you two quick questions.
Yeah.
One is, when you pull results out of burp automation, I mean, like any tool, there's going to be a significant number of false positives. Where does the human review aspect fit in this equation? And number two, suppose I'm a CISO and I have like 1,000 different applications, all the different technology under my belt to manage. How do I scale these methodologies to a large number of applications?
Yeah. So I think the very first one, the point about how do you mark false positives so that you don't include them in subsequent tests, for example. At the moment, the framework doesn't include that. What you can do with JBehave is you can mark particular tests to be skipped. So you can skip an entire test. For burp, that's a bit useless because you don't want to skip the entire SQL injection scanning part just because one particular result was a false positive. So I think that's something that I'd have to develop into the framework so that a human, for example, can just tag the XML result and say, I don't want to see this again. I know about this, or I don't care about this, or it's a false positive, and don't show it in subsequent results. As for scaling, I don't see this as a tool that can easily be scaled from a CISO point of view. I'd rather see it as a tool that developers could use for their particular application. So if they're the ones developing an application, they could use this tool and run it against their app. And hopefully they would use it within their continuous build environment, or they'd use it within Hudson or whatever, and use it the same way that they currently use for integration tests. Yeah. Yes. Yeah. Yeah. Sure. Burp will test everything that it sees in the traffic that you send through it. So if the login field contains hidden fields and you submit that login form, those fields will go through Burp, and Burp will see those parameters. And as soon as it sees those parameters, it will include it in the scan. Yeah, yeah, sure. Yes? Mm-hmm.
Have you got anything in Bdd side that's particularly good for handling that on tests, say, or wizard form?
Well, I think the only thing to do with those type of forms is to be very careful about the page objects that you generate, and be very careful about the data that you throw to those pages. It's probably also good practice when you're writing page objects to build error handling code in them. So particularly if you have wizard forms, if there's an error, any part in the process, your code, your page object should be checking for that error and throwing an exception saying, I've only got to page number 2. Don't bother sending data to page number 7 because I haven't got past the page that I'm at. So there's no kind of generic solution for that. You just have to be very careful about how you write your page objects in your Selenium code. Any more questions? No? Great. Well, thank you for your time.